everyone. Next up, let's welcome Yuriy with threat mitigation. Yeah, with the future of threat mitigation. Thank you.
Hi, everyone. Thanks for coming. It's excited to see all of you here. My name is Yuriy. I'm a data scientist in a threat research group at Imperva from Israel. So Imperva is a leading cybersecurity company that's been around since 2002, focusing on application and data security. We provide our customers a wealth of solutions, including web application firewall, anti-bot, DDoS, client-side protection, and many more, handling tens of billions of requests per day. And in the recent year, we were acquired by Thales Group, and we joined its Digital Identity and Security Division, DIS. Today, I'm going to talk about a recent project I've been working on in the past year or so. I think it's an interesting project that raises cool questions, and I'm excited about it. And it's about using generative AI to automatically generate web application firewall rules and solve additional problems. And I will explain everything that I just said, so don't worry if you didn't understand anything of that so far. So my plan in the 40 or so next minutes is as following. I want to explain first time to mitigation. What does it mean about patching, why it is important. Then we're going to talk briefly about web application firewall. What does it do? Then we're going to go into the process of security analyst and how it is combined with the web application firewall. Then we're going to discuss what are CVEs, if you haven't heard about them yet, and how they are treated. Then we're going to dive deeper into the process, see which tasks security analysts should do in this context. And we're going to talk about the challenges in these tasks, how we solve them using AI assistant, and what lessons can we learn, and what's in there for you if you use generative AI, which I guess nowadays most of us use in this way or another. So the first thing is time to mitigation. Time to mitigation means how fast can we mitigate a vulnerability after it was published. So you all might remember the Log4 shell. Log4 shell is a notorious vulnerability that was found in December 2029 in Log4j framework, which is a very widely used Java framework for logging. And this vulnerability is of type remote code execution, and it allowed an attacker to download a code of his or her choice to the compromised machine and then execute it from remote. This was really a crazy vulnerability. And in our data, in Imperva, we saw that after around 12 hours since it was published, the number of attacks using this vulnerability were more than 200,000. So this answers the question that people sometimes ask, like, is it really important to patch our systems? Maybe some vulnerabilities are, staying there in the wild. Nobody cares about them. Maybe it's something like life insurance. We buy it, but we never plan to really use it. So I think this graph answers this question. And if you think that it's only something that is because of this vulnerability was so widely known, then I can tell you that in many, many cases, even for vulnerabilities you never heard of, we see very similar graphs. Of course, the number of attacks varies, but as soon as something like that is published, then the number of attacks is rising. And this, okay, so if we agree that we have to patch our systems fast, or at least we should strive to do so, let's see if it's an easy task. So imagine you have some website or some infrastructure. You have many components. Some of them you developed in-house. So these, without specific icons, represent the ones that are developed in-house, and the ones you recognize represent something like third-party components. And let's assume that you've been told by some miracle that these components that are here highlighted in red, Thunder, they are vulnerable. And then you will try to patch them, so you search for a patch for each and every component. Some of them you can do it successfully, and some of them fails. And it's really a big mess. So the first thing is how to detect which components are vulnerable, right? We have hundreds and thousands of lines of code. Some of them we wrote, some of them we use in some library, some of them are third-party components. So there are products and systems that help us to detect these vulnerable components, but it takes some time, and it's not an easy task. And even if we did that, then we need to patch each and every one of them. And these patches can create issues because these patches, to apply a patch means just downloading some recent version of the product of this library, but maybe they have an interoperability issues, broken APIs, so then our components stop communicating between them and everything stops working. So this is another problem. And also, it is not uncommon to see cases where vendors take, let's say, 1 month to patch their product. So as you saw in the previous graph, after 12 hours, you might be doomed. So 1 month is just too slow, or whatever time it takes for them. And another interesting research I saw recently in the context of Log4Shell vulnerabilities, that as of December 2023, which is 2 years after publication of this vulnerability, something like 30-something% of applications were still running vulnerable versions of this component. So you can see what a mess it is. So now let's see how Web Application Firewall solves this problem. So instead of using local patching, instead of patching each and every component, we can do virtual patching. Virtual patching means that we apply the patch on the network level, but what it means in a more simple words is that actually we use a thing that is called Web Application Firewall. So are there people here that never heard of it? Raise your hand if you never heard of Web Application Firewall. Okay. So most of you have heard. So I will be brief about that. So it's a network security product that is placed between the client, which is you and me if you're accessing some website, and the website that you are running. So let's say you can put the Web Application Firewall on premises if you're running for some reason your website on premises, or you can put it on the cloud and redirect requests to it using DNS or other techniques. And then what it does, it inspects every request, incoming and outgoing, and it can do various things with it. It can, first of all, it has to, so the attacks that Web Application Firewall helps us to protect are, for example, SQL injection, cross-site scripting, remote code execution, path traversal, and all other attacks. So it inspects each and every request, and since it is application, user, and session aware, it knows what to do with it, and if it's a malicious request, then it can drop it, it can challenge it, or do all kind of additional interesting things with it. But ultimately to protect the website from such a request. And the interesting thing about WAF that is relevant to our talk is the security engines. So security engines, it's a subsystem of almost every Web Application Firewall, and it is divided into several types. So it can be rule-based, and it can be fuzzy logic, and by the way, it can combine both solutions. So rule-based means we have some set of pre-configured rules, and fuzzy logic means that we use certain heuristics or machine learning techniques that gives a score to each and every request, and by that score it decides if to allow it or not. And also we have this model of positive versus negative security. So imagine the negative security as a blacklist, meaning that these types of requests we don't want to let through, and the whitelist says only these types of requests we want to get through. So in this talk I will refer to the blacklist, which is the more common model for the web application firewall. Of course, another issue is that usually we have the managed rules, namely the rules that come as shipped out of the box with the WAF, and the other type of rules are custom rules. So these are rules that the customer adds for all kinds of its own reasons. So since today we're going to talk about automatically generating those rules, let me give you a simple example of a rule. So a rule would contain a set of predicates. In this case, we have two, like URL and parameter. And we want to see in this simple rule example if it contains the WordPress admin endpoint, and if in one of the request parameters somewhere we didn't specify here where, maybe it's in the payload, maybe it's in the query string, it says username. And of course, the other important part of the rule is the action. So what do you do when you encounter such rule? And the action, as I mentioned, could be log it, block it, show captcha, or whatever. So let's see how the process of security analysts is related to that, and how these rules are come from. So as you might imagine, the rules are not created just by themselves. There is a lengthy process that makes them to be born. So first, we need to search for security vulnerabilities, and I will talk about them in the next slides. They can appear in a variety of sources and in a variety of forms. So after we search, after we get some vulnerability, we need to understand its applicability. By we I mean the security analysts. So they need to understand if the vulnerability is really applicable to a web application realm. And then to understand, maybe it's an esoteric vulnerability, maybe we don't care about it, or maybe it's something like log4shell, which is very important, and to see if it's already covered in the WAF or not. And eventually, if the answers to the above question is positive, then we need to create the specific rule, and we need to manage it, because as time changes, attack changes, so maybe the vulnerability is published, and then after a while, it's used in a different way, so we need to update the rule to follow up with it. And as you imagine, all this takes a lot of time, and hint, we want to automate it. What is vulnerability? If you never bothered to look, CVE stands for Common Vulnerabilities and Exposures, and there are many, many sources on the internet where they can appear. The mitra.org is one of the notable sources. And let's look what key components they have. So every vulnerability has an ID, a number that from the number you can see specifically the year of the publication, when it was published, when it was modified, and what product is the vulnerability refers to. And also an important thing is the score. So the severity scores tells us how severe the vulnerability is. If it's something approaching 10 or 9, it's very, very crucial. And if it's smaller, then we might not care. And it also has a category hierarchy. So it shows which exactly type of attack the vulnerability refers to. Okay, this summarizes what I just said. And the question, where do we find these vulnerabilities? So the first venue is news type articles. So sometimes the vulnerability is published and it looks like this. I do not expect you to read it because it's too small. But basically, after you read the whole text, you can see that it only says, hey, the vulnerability was published, and nothing much more than that. So that's the first type. And of course, it's also important because it tells us, okay, it's something we want to follow up, we want to look on, but as an immediate action, we have nothing to do with it. The second type of publication is technical blogs like this. For example, PacketStorm is a well-known site for that. And here you can see a much more detailed description. Specifically, you can see here a code that is a proof of concept for exploiting this vulnerability. And if you look in the code, you can see key components here, which is the URL, some parameters that I used. So this is already something very interesting that allows us to do something about it, specifically to build the WAF rule. And of course, the best thing we can find is something like this GitHub repository, which also contains not only the code, but a bunch of specific instructions, how to run the vulnerability. Maybe it contains several files of code. So this is a best source for us in this context. Okay, now let's dive deeper into the process and see how the security analysts go with this thing. So the first thing is that they, in our company, and I guess in other places, they don't really go and look actively on the web for the vulnerabilities. We have an automated system that does that for us. And this is, I guess, a topic for another talk, but this system also employs large language model, and it browses all the sources I mentioned before and summarizes them into a feed that the analysts look on. So this feed has several columns, and they can filter it according to whatever they like. So for example, if they want to look on the only critical vulnerabilities, they can do that. And if they want to look on several keywords, they can also do that. So to begin with, they have a feed that is just streaming on them, and they can choose a vulnerability out of it and handle it. But when you have the vulnerability, as I already started to mention, you have to decide on several things. So first of all, you have to understand if it's relevant for the WAF. And I will give you an example in a minute. Then you have to understand if it's informative, as I showed you in the news type article, if it allows us to create the rule or not. They have to check if it's already covered in the WAF, or maybe we have, maybe the vulnerability is new, but we already have a bunch of rules that cover these vulnerability exactly. And if the answer to these questions is yes, yes, and no, then ultimately they have to create the rule. So the first task is in scope or out of scope classification. So in this example, you can see that this vulnerability talks about D-Link routers. I guess if you have a home router, good chance it's a D-Link or TP-Link or something of that kind. And this is clearly not relevant to web application security domain, because these are home routers and they are not used in large organizations. This is not something that we are interested in. So in this case, it's not in scope. On the other hand, if we have something like this, then this article says, okay, this is Java deserialization security flow, and this allows remote code execution. So you can already understand that you need to browse through all this text, and in the end, it seems that is relevant. After deciding if it's relevant or not, if it's not, of course, they drop the vulnerability. The second thing is they have to understand how useful is this piece of information. So, as I mentioned before, I showed you a news type article that it wasn't useful, but sometimes it's much more complex. So, this is an example of text that describes the vulnerability. It has many, many links. So, if you go and read through each and every one of them, as I did for the sake of this example, you can see that it doesn't provide you any useful information. It's only talks about all sort of satellite information, but it doesn't allow you to reconstruct the attack or to build a rule. And in this example, however, you can see that this description points to a blog post of this guy. And if you go there, you can see that you have a specific code examples. And here I omitted a long bunch of code before this thing. And this allows to build the exact rule to stop the attack. As I mentioned before, the last thing that they're gonna check is if we already covered. So they have to go and search into all the existing WAF rules, and we have thousands of these in our system. And I'm sure that this is not something extraordinary. Every serious WAF product has a lot of rules, so you have to go into all of them and to check if you already cover the specific vulnerability. And in many cases, it is covered. Okay, so let's talk about the more interesting task, which is creating the rule. If we passed through all what I said before, and we decided that we need to really come up with a rule, so what the security analysts have to do in order to do that? So first, they have to know the exact syntax of the web application firewall. I showed you an example of several keywords. And actually, we have many parameters in our WAF, not only URL and parameter, but of course, many other parameters. So you have to know the syntax. You have to make sure that the rule balances between not being too specific and not being too general. So if it is too specific, let's say the article talks about very, very specific payload, and then maybe the attacker changed the payload a little bit. So if we are too specific, we will probably catch nothing. Okay, so the rule is going to be too general. And if we're going to be not too general, like we will make a very wide rule, it will just catch the whole traffic. So it will result in false positives, and this is also very bad because if we are not stopping the attack is bad, but if we are blocking legitimate traffic is very bad because it can cause our customers a lot of money, cost them a lot of money. And there are several additional guidelines. For example, use regular expressions efficiently, create short and simple rules in order to be able to maintain them easily. So as you can see, this is a non-trivial task. And you might ask, okay, so we understood that there are these problem of creating the rule, but maybe if we look on all the CVEs, some of them are not applicable, as I said, to the web application firewall, and some of them are not in scope, and some of them are non-informative. So maybe we are not left with many, many CVEs. And the answer is that, according to CVE.org, we have something like 100 vulnerabilities that are published every day. And it's, of course, increasing with time. So according to one research from 2022 to 2023 in June, it increased twofold. So as you can imagine, it's clearly unscalable. We cannot just hire endless amount of security analysts. So this problem begs for automation. And by begging for automation, the question is, okay, can we replace the analysts altogether? And the answer is, for now, not really. Maybe, maybe one day in the future. But right now, the WAF is a critical component, as I mentioned, in the network. And the rules precision is very important because if we mess there, then either the traffic stops flowing or we miss an attack. And also, the LLMs right now has the hallucination problems. So what we decided to do is to build an AI assistant to help the analysts. So it turns out that the time that is being spent on each rule is something between 10 to 60 minutes. And it is divided as follows, something like 10 minutes to filter relevance, and then 20 to 50 minutes to create the rule, to reconstruct the attack. And this is clearly something we would like to improve because we want to improve the time to mitigation, as I mentioned in the beginning. And what we were able to do is we were able to solve the relevance filtering problem, which I will talk about in a second, and the rule creation problem for most of the cases. So to do that, we had to create a data set to train our models or to test the models. And the data set has to take into account, first of all, the distribution of the attack types. As I mentioned before, we have several types of web application attacks that are relevant for us, like SQL injection, cross-site scripting, and so on. So we wanted to make sure that in the data set, we give representation to all these types that interest us. Also, we had to make sure that the difficulty of the rules is diverse in the data set. So we give representation to difficult rules and also to simple ones. And also, there is the point of being affected by traffic. So as I mentioned, since the managing of the WAF rule is a continuous task, in many cases we have rules that are changed after the fact, after the publication, following the traffic we saw in our actual client's infrastructure. So we wouldn't want to use these rules to train our models because the model doesn't see the traffic. We want to show the model only the description and then make it create the rule. And given rule description, as I showed you in the examples before, first we wanted to translate it into text. So the first task is just to take some URL and to scrape the text out of it, but there are also more complex cases where it shows in many such vulnerabilities we can see images that show the proof of concept example or even videos that show it. So we need to translate these into a text, and we use some libraries to do that. And also, OpenAI has capabilities in the GPT family of algorithms that you can give it an URL and it browses them and does it automatically for you. So to solve the classification task, the classification task I mentioned, in scope, out of scope classifications, and also informative and non-informative classification, turned out that it was fairly easy. We had to build a data set and to do prompt engineering on a not very complex level. And this is because text classification is a very natural task for large language models. But when we came to the rule generation, it turns out to be a much more complex task. And it involved an extensive and iterative prompt engineering, some manual analysis, hallucinations that we encountered, and teaching LLM the syntax. So let me introduce several challenges and talk about the solutions for them. So the first is, as I mentioned, a bad syntax problem. I mentioned it that it is bad, but the question is, okay, maybe the WAF can work with a rule that is not exactly precise in terms of the syntax. And the answer is not really. And of course, we have many mechanisms that guideline this thing, but if you give it a bad rule, it might just throw an exception, and then the product stops working. So the first attempt for us was to validate the syntax that is generated by the LLM and ask it to fix it. But it didn't work very well. And it turns out that much simpler solution was to just do better prompt engineering by provide more precise example of the rules and specific guidelines. For example, how to use specific predicates and what to do in specific cases. The second challenge was evaluating this rule. So so imagine that we have the data set that I mentioned before, and we need to evaluate it somehow. So we have, like, let's say 100 cases of CVEs, then we are receiving 100 rules generated by the LLM, and then we change something. How do we evaluate this? And manual review was very slow and painful. I did it by myself in the beginning, but even if you use temperature 0, if you are aware of what that means, and if you're not, then this is a parameter that governs how inventive the LLM is. So even if you set it to 0, some changes may occur between every run, even for the same input. And then, for example, the order of clauses may change. And this looks not really, looks very different, but it's actually the same rule. So to cope with that problem, we created an automatic similarity score. An automatic similarity score, what it does is it divides rules into clauses and checks the predicates and penalize for missing predicates, penalize for excess predicates, and for all the matching ones, it measures string similarity between them. So let me show you an example. So in the case of these two rules, you can see that they are identical, only order of the parameters is different. So the method here is in the beginning and method here is in the end, but all the rest is the same. So here the similarity is 1. However, in this case, the specific URL parameter is different. And in this case, we would like to say that similarity is about 0.6, because you can see that the half of the rule is exactly the same, but then for the other half, we want to give it a good part of recognizing that it's the URL parameter, but we want to penalize for coming up with totally different value. And of course, there are many other examples, like this one, where the similarity here is something like more closer to 1, because it's already almost the same, but not really. Okay. And in the last couple of slides, I want to share our practices, our tips and best practices for prompt engineering that we encountered in this project. So the first one is giving LLM a role. As you might have heard, these models today are multi-model, so every model consists of small submodels, and the importance of that is crucial because it allows the model to really route your input into a correct model. So for example, if you say, you are a seasoned security analyst, and you are talking about WAF rule generation, then it might help to create a much more precise rule. Another surprising thing we found out is that you don't have to be polite. So it was in some article I read, and I thought that it probably doesn't work. But after removing all these words from my prompt, I learned that the results were significantly better. So I don't know if it looks like, you know, a bug or feature. It's not clear. Maybe it's something that is being addressed already in recent models, but you should try it and see for yourself. Another powerful technique is chain of thought. So it's very well known if you're talking about some mathematics problems. For example, if you want your LLM to solve, I don't know, a math problem from some school assignment, but also in the more complex tasks like generating a rule, it's very useful to tell it, let's think step by step, meaning that the LLM will output the process of its thinking, and therefore usually the results are much better. And even more powerful extension of this approach is what's called tree of thought. And this is really something that, if you haven't seen, it's really cool. So you instruct it to imagine several experts having a conversation, and the number of experts doesn't have to be huge. It doesn't have to be 100. Let's say you can use 3 or 5, and then you can see that the output is a conversation between some seemingly people or experts, and some of them leave the conversation, some of them remain, but the results also are much better. And the last nice thing is that every LLM has its own specifics. In the case of Claude, for example, if you take, or let's say you have some prompt that you are using with GPT family of models, and then you suddenly want to translate it and use it for Claude, then adding XML tags helps a lot, because Claude loves when you divide your input into XML fragments. Okay, so to sum up, at first when we came to this project, our task was to create rules automatically, but it turned out that even in many cases the rules are not required. And when we helped our analysts in deciding about the classification tasks I mentioned, in scope, out of scope, and informative, non-informative, it really saved a lot of time for them. And we saw that in many, many cases, we don't even reach the point where we need to generate the rule. And that was very interesting. As I mentioned, some problems are natural for LLMs, like classification, text summarization, and some of them are not so much, like rule generation or code generation problems. Another thing I said is about prompt engineering. I think many projects in the generative AI area today are using extensive prompt engineering, and that's kind of the focus of this project. And indeed, it was one of the key parts in our project, because this is something that really affects the result tremendously. The hallucination, as I mentioned, is an issue, and our solution to them was partially by using the score function I mentioned and other techniques, but it's something that we couldn't solve completely. It's something that you have to be aware. So if you have mission-critical systems or systems that do some automatic action following the LLM output, I would recommend to really carefully review them and place some guards and some functions that really verify the output and not automatically, I don't know, send emails to millions of people or stuff or anything that is mission-critical. And in the end, as I mentioned, shortening the time to mitigation was our ultimate task, and this is where we succeeded. Okay, so that's what I roughly had to say. So thank you, and please ask if you have any questions.
Yeah, Yuriy, thank you so much for a great talk. That was really insightful for me. I just want to take a step back in the power of WAF itself, right? So if you consider that we will improve this process of automating the security analyst as much as possible, and that the data of publication of CVEs will be more robust and complete. Do we need any other security controls then?
What do you mean?
I mean, we have been using this, this statement, right? My security is in place because I have a firewall. Now we're talking about application security, web application security. So if the WAF is that effective, I'm just curious about the future if we're going to be able to create these rules really on the fly, the right way, with least amount of false positive, hopefully false negatives as well. Are we secure in the future? Do we need any other controls? Like we had to talk before, talking about SAS, RAS, DAS. I'm just trying to understand your take on that.
Yeah, I think it's a good question. You know, I think that this cat of mouse race is not going to end because the attackers are increasingly use also generative AI and LLMs and make it much more difficult. I think what I hear in your question is, can we do the WAF instead of rule-based, maybe machine learning-based? And definitely it's something we are thinking on and working on, and many companies out there are doing it. I know from my experience that it's a really tough problem because since it's so mission critical, so imagine the budget that you have to handle each request is really, really tiny, okay? And I don't want to talk about numbers, but you can imagine that it's somewhere between milliseconds and nanoseconds. And to do a machine learning model, something really interesting, it's a challenge, even if we're not going into the LLM domain, because there it takes much more time, right? You can talk with ChatGPT, it can think for, I don't know, well, no matter which model, it can think for, I don't know, for 30 seconds. It's unacceptable. So I think it's a tough problem, and let's see. But the future is really interesting on that. So yeah, for sure.
Thank you. Anyone else? Yeah.
Thanks for the talk. Have you maybe noticed some differences in comprehension between OpenAI's models and, for example, Claude's models in how it perceives security and how it outputs configuration that it generates or something?
Yeah, sure. We've been playing with that. So fortunately, in this project, we're not using private information. So for those of you who don't know, there are all types of deployment scenarios. So let's say that we have our customers' data and we want to use it with these models. So there are deployment scenarios where we do not send the data to OpenAI. For example, in Claude, there's the Bedrock for AWS. So there we have the model in AWS, infrastructure, and therefore the information never goes to Anthropic for Claude. But specifically to your question, from what I saw at the time, GPT was the most powerful, but Claude really approaches it in terms of the quality. But it also varies on specific tasks. So I think rule creation is really, really tough. And there I saw that Claude is not as good as ChatGPT, GPT family of algorithms for versions like 4, 4.0. But it improves all the time, so you have to really monitor it all the time. All these models tremendously, they evolve as we speak. And Llama is also a very interesting model. So I think it's something that you should really check and see, and remember that every model has its own deployment versions and requirements, and something may suit you as an organization, something not. So it really boils down to a lot of technical details, not always like what model is the best, because all of them are pretty decent these days, and they only improving and improving, and and we are coming into a situation where like all of them seem to do an amazing job.
Thank you. Let me move around this part. Anyone?
Thank you for your talk. We built something similar, but more in the terms of advisories other than rule generation. And one problem we had is that often CVs don't have all the references yet, or there are new proof of concepts coming out. How do you handle updating information for older or a bit older vulnerabilities?
Yeah, so as I mentioned, we have this system that I didn't really talk about of creating the feed. So we have the system that scrapes the web, and every vulnerability, every piece of information, it just pops there, and we grab it, and we see if we have it already or not. So what happens is usually for the first time that something is published, we usually don't have any information, as you mentioned. So we just put it in our database, and we say something like, not enough information yet. And the next time when some piece of information comes, we know by using the ID of this to find this, this vulnerability. We see that we haven't addressed it yet. And then the piece of information that comes in, we examine it like every time. So by this scraping mechanism, we make sure that we don't miss anything. And this mechanism just summarizes the publication, and then it goes into the process I mentioned. So after some summarization and after we decide, okay, it looks like it's relevant for us, then we run it through the model that says, okay, applicable, in scope, etc., and then we try to create a rule out of it. So that's how we don't miss anything. And of course, the security analysts, they are in the loop. So we haven't been able to replace them, and we don't want to yet. So they are looking on that. It's not that it's so automatic. Like, look on each and every one of them, and they know, okay, this is interesting CVE. You know, they remember all of it. That's why they are great security analysts. They remember all of these numbers. They say, okay, this is important. We saw it last month. Let's see what's new there.
Thank you.
Yeah, I have a question about the scraping mechanism. How often are you running it, and on which data sources? Since it seems to me that if you are running solely on OpenAI's models, the costs could get quite high if the scraping is too often and you are running whole evaluations on that data.
Yeah, so for now we don't have any issues with the cost. We run. I don't want to really say how often we run it, but we run it on a daily basis, and even more than that. Yes, and we have all kind of sources I mentioned. So we looking on Telegram channels, on some Twitter, tweets, and of course blogs and all that. And there are also some sites that aggregate this information. Some interesting sites that have an aggregation and even APIs that let you see recent vulnerabilities. So we are doing all that. And until of now, we don't have cost issues. But remember that Imperva is a big organization. So cost issues, it's something that if you and me are going to make our own product, maybe we're not going to make it, right? But Imperva is a big company, and they have the budget for that.
Thank you so much. That was our time for questions. Let's give it up one more time for Yuriy.